All right, so lastly, after our sine and our cosine, let's consider the graph for the inverse tangent function. So this is what it looks like, and you can see it actually does resemble the tangent function, but just it's going to be reversed in that line. And now the domain, as you can see, because this keeps going on forever, doesn't it, on either side. So therefore the domain is all real x. But the range is between pi on 2 and negative pi on 2. And importantly, these are asymptotes here. If they're asymptotes, it means that you can't ever touch them. So that's why the range is greater than and then less than. Can you see that? There's no equal to. And that's really important because a lot of students get used to writing greater or equal to for your sine and cosine inverse functions. So just remember, for your tangent inverse function, there is no equal to there, right? So let's remember, this is what the inverse tangent function graph looks like. The domain is all real x, whereas your range is between pi on 2 and negative pi on 2. Okay, so I'm going to show you how we get all these values now. So firstly, let's sketch the inverse tangent function. And to do that, we need our normal tangent function, which we have here, and these are our asymptotes. Yeah, remember this is at pi on 2. This here is going to be negative pi on 2 asymptotes. Now, this is our y equals to x line, where it's going to be reflected in. You can see this is going to be difficult to reflect. So before I show you the reflection, let's just consider bits and pieces of it. So let's just consider the middle part for now. This portion, when it's reflected, is going to look over that way, isn't it? Whereas that is going to look like that. So you can see it's going to become what we can see as the inverse function is defined as. Whereas that will be flipped over there. And this over down here. So this is what it ends up looking like. And you can see the middle portion is quite easy to understand why it's like that. But just look at this line here. You can see how this gets reflected all the way over here. Whereas this here, this white line here, gets reflected all the way up there. Now the other thing that we have to consider in this that we didn't really have to in our sine and cosine is the asymptotes. So if this is at pi on 2 and negative pi on 2, the asymptotes are also reflected in the y equals to x line. So this line over here, this asymptote, is going to be pi on 2 up here and then negative pi on 2 down here. Does that make sense? Because this becomes reflected up here, whereas that becomes reflected down here, right? So this is our curve for y equals to inverse tan. But now I want to consider it for the largest domain of this so that it is also a function. And to do that, we need to perform the vertical line test. So putting that in, you can see it's always going to cross multiple points unless we get rid of the top and the bottom and only leave this. So that's why this is defined as our inverse tangent function. So the largest domain of that is just going to be all real x because it keeps going forever either way. Now, what about the range of this so that it is a function? Remember how I said the tangent has asymptotes at pi on 2 and negative pi on 2? And when we did the inverse of that, the asymptotes also were reflected. So that's how we get the pi on 2 asymptote and the negative pi on 2 asymptote there. So therefore our range will be greater than negative pi on 2, but less than pi on 2. Remember, without the equal signs. Great. So now you understand this is how we get our domain and range and also the curve for our inverse tangent function. So now let's work through some questions where we're going to alter the basic tangent function. Okay, so here we have our function of y equals to inverse tangent of the absolute values of x. So let's find the domain. Well, what I want you to consider is that this here, x, is going to, the domain for that is all real x, isn't it? So if we find the absolute value of that, it's still going to be all real x. So therefore the domain is all real x. Now let's consider the range of inverse tan absolute value of x. Now, because we're finding the absolute value of x, we're only finding the positive portion, aren't we? So because of that, we'll only be considering that portion. So from this graph, we can work out that the range is going to be greater or equal to 0, yeah, but less than pi on 2. See how very careful you have to be with your range domain in tangent? So sometimes you will need it equal to, because you can see it can equal to 0 there, but it has to just be less than that, yeah? So now we've worked that out, I want us to sketch this function now. So sketching that, remember absolute value of x means it's reflected in the y-axis, whereas the absolute value of y means it's reflected in the x-axis. So we can just sketch this, but reflected in the y-axis, so it looks like that. Now, previously with our inverse sine and inverse cos, we used the input to work out the domain and the output to work out the range. Now, we can do that for tangent, but it's really difficult to use the output. So the best way to work out the range for your tangent is to either graph, as we've done here, or use the domain and alter that to look like y, okay? So over here, we've used the graphing method. Now, I'll show you the domain method later on. Okay, great. So now I've sketched this. Let's move on to 25. And here we're presented with a new function, which is y equals inverse tangent of the square root of 1 minus x squared. Now, to find the domain, we can still consider the input. So this here is going to be our input. Now remember, your input for tangent is all real x. So this must be all real x. Now for this to be real, what must 1 minus x squared be for it to be real? That's right, this must be positive. Yeah? So that's why we can say that the domain of this exists for 1 minus x squared greater or equal to 0, because that's when it's positive. Yeah, can you make the link of how we go from this question to our very first step there? Great, and now we just need to work that out. So we just change that, so multiply everything by -1 and then we change the sign. So that becomes x squared minus 1 is less or equal to 0. Move the 1 to the other side, x squared is less than 1. Now, how we get to this step here is we do need to do a couple little steps in between, and we have learnt this before, so let's just revise it. So from this step, we can factorize that to x plus 1, x minus 1 is less than or equal to 0, correct? Now remember how this, we can just draw a really quick sketch, doesn't need to be nice at all, and the x-intercepts is going to be at 1, at -1, x is positive, so it looks like that. Sorry, that's 1 there, that's positive 1 there. And now we think, when is this less than 0? Well, that's when it's less than the x-axis. So it's going to be this portion here, which is between -1 and 1, isn't it? Including those values. So therefore, that's how we work out that x must be between -1 and 1, but also including those values. So that's the domain worked out. So this is actually just a really quick sketch. I've just drawn it large so you can see it, but in your exams, you just need to do a really small one. Doesn't need to be neat at all. It really is just for yourself to confirm whether this is going to be between those values or greater and then less than, yeah? Excellent. So we've worked out the domain for this now, knowing that this had to be real. So therefore that had to be positive. Let's move on to finding the range of this. So remember how I said we don't want to use the output method. We want to either graph it or use the domain. You can see that this is going to be a little bit difficult to graph, isn't it? So let's use the domain method. So that's what you do. Check, is this going to be easy to graph? Probably not. So let's use the domain method. And what you do here is start off with the domain, which we worked out to be between -1 and 1. And then we want to alter that, so add and multiply things, so it looks like this entire thing here. Yeah? Okay, well the first thing we want to do is make it x squared. So squaring that, it's going to be between 0 and 1 because it makes it positive. Yeah, x squared makes a positive, so it gets rid of the negative values. It now must be between 0 and 1. And now we need to make it negative x squared, so multiplying everything by -1, this becomes -1, that stays as 0, and the signs are flipped. Adding 1 to both sides, that becomes 0, this becomes 1. And now we just need to square root everything. That stays the same, but this is square root. So we have gotten this portion here. Now we just need to multiply everything by inverse tan, essentially. So that's what we've done here, just multiplied everything by inverse tan. So you can see that this now looks exactly like y. So we found out the range, we just need to tidy everything up a bit. So we just think to ourselves, tan of what equals to 0 and tan of what equals to 1. So that's going to be 0 and pi on 4. So therefore our range is going to be y is bigger or equal to 0 or less than or equal to pi on 4. Yeah? So can you see how this is great? This has equal to, even though with our original tan range we didn't have equal to, because we're working from the domain here, we do have that there, okay? And you can have that with some of your tangent inverse functions. Excellent. So that's our range that we've just worked out and worked out the domain. And as I said, this was too difficult for us to sketch, so we'll just leave it as finding the domain and range for that question.